All right, today we're going to talk about a piece of technology that is literally changing medicine and science all over the globe. And no, it's not some fancy supercomputer or a high-tech robot. It's a microscope. And it's made almost entirely out of paper. Yeah, you heard that right. This quote really gets to the heart of what we're talking about today. It's this idea that, sometimes the biggest, most powerful ideas, they don't show up all shiny and complicated. They just arrive folded. I mean, think about it. We live in this incredible era of AI, robotic surgery, brain-computer interfaces. It's amazing stuff. And it's so easy to think that that is what progress has to look like. But what if a truly revolutionary tool was, well, just a simple folded piece of paper? That's the whole idea behind the Foldscope. Okay, so to really get why a paper microscope is so important, we have to back up a little. We need to understand the problem it was actually built to solve. And that problem is what you might call the billion-dollar barrier created by traditional microscopes. Microscopes aren't just for some pristine, high-tech lab. Far from it. In so many parts of the world, they are the absolute frontline tool for public health. We're talking about diagnosing infections, spotting the parasite that causes malaria, checking if the water is safe to drink. In a field clinic, a microscope can be the one thing that separates a life-saving diagnosis from just a guess. I love this analogy. Think about a regular microscope like it's a super fancy sports car. It's amazing, right? But it only works if you have perfect, smooth roads, a team of specialized mechanics, and a constant supply of premium fuel. It's awesome under perfect conditions. But take that car to a remote village with dirt roads and no power grid, it's basically a very expensive piece of metal. Useless. And that's the heart of the problem with conventional microscopes. They're heavy. They're fragile, they're super expensive, they need electricity, and they need people who know how to maintain them. All this stuff creates these huge barriers, and it effectively locks billions of people out from the basic benefits of modern science and medicine. So the solution didn't come from trying to just make a slightly cheaper, slightly lighter version of the same old machine. Nope. It came from a totally different place. It all started with a simple but really powerful question, one that was actually inspired by origami. And this was the question. What is the best microscope you can build for less than $1? Think about that. The goal wasn't to make something 10% cheaper. It was to make it for literal pocket change. That one simple constraint forced a total reinvention. It meant throwing out the old ideas of metal and electronics and turning to something completely radical: paper. And here it is. This is the Foldscope. It is a fully functional, real optical microscope. It weighs less than a coin, you can drop it, you can even stomp on it, and it'll still work. And it gives you powerful magnification. And it's all done through these incredibly clever, precise folds in a single sheet of paper. Just amazing. And using it is just as simple as its design. You literally just insert a sample slide, point the Foldscope towards a light source, the sun works perfectly, and you look through the lens and focus. That's it. No complicated setup, no plugging anything in. It's science made radically, beautifully simple. Okay, so this is a really clever idea, right? But how does it actually translate into real-world impact? Because this isn't just some cool prototype sitting in a lab. The Foldscope is out there, right now, being used in clinics and classrooms all over the world. And in healthcare, the applications are genuinely life-saving. You have health workers using them to spot the signs of parasitic diseases like malaria. They're using them to look at blood samples in tiny clinics that are miles and miles from the nearest hospital. They can even use them to do a quick check to see if the village water supply is contaminated. It's incredible. Let's just talk about the money for a second, because this is wild. If you wanted to equip 100 clinics with traditional microscopes, you'd be looking at a bill for over $50,000. To do the exact same thing with Foldscopes, it would cost you about $100. That isn't just an improvement. That completely changes the entire game. It just rewrites the rules of who gets access to this technology. And this impact goes way beyond just medicine. Think about education. For so many students around the world, the microscopic world is something they only ever read about in a textbook. But the Foldscope puts that world directly into their hands. Suddenly, they're not just reading about science. They're doing science. They're exploring pond water, looking at pollen, checking out insect wings. It transforms science from this abstract idea into a real, hands-on, personal discovery. So you see, the Foldscope really isn't just a clever tool. It represents a whole different way of thinking about progress, about what innovation really means, especially when we're talking about medicine. Yeah, It's a perfect example of this idea called inclusive innovation. The goal here isn't just to invent something new and shiny. The goal is to invent something that everyone can access and use. It's proof that the most meaningful solutions don't have to be exclusive. They can be for everybody. And what's really fascinating to me is how this seemingly low-tech tool actually supports some of the most high-tech trends in modern medicine. We hear all about decentralized healthcare, personalized medicine, preventative screening. Well, all of those things depend on one thing: having accessible tools on the ground. The Foldscope is that crucial first step. It really brings home this point that the future of medicine isn't just about replacing humans with machines. It's about giving more humans the right tools to do their jobs better. It's about empowerment. It's about giving that local health worker or that curious student a tool that just blows open the doors of what's possible for them. So when you boil it all down, the legacy of the Foldscope is about so much more than just a clever piece of folded paper. It's about the powerful lesson it teaches all of us about what innovation really is. It really challenges our basic assumptions, doesn't it? We're kind of trained to think that progress has to mean more complexity, more features, higher costs, but the Foldscope just proves that's not always true. Sometimes the most profound progress comes from making things radically simpler, radically more accessible. And maybe this is the ultimate takeaway. The true measure of innovation isn't just how technically brilliant it is. It's about who gets to use it. It's about how many lives it can actually touch. It forces us to ask, who gets access to this? Who is being empowered here? And by that standard, this simple little paper microscope, it might just be one of the most important innovations of our time. And that kind of leaves us with one final big question to chew on. If a single sheet of paper can totally democratize access to the entire microscopic world, what else is out there? What other complex, expensive, inaccessible technologies are just waiting for their own simple reinvention? What else could we unlock, not with more complexity, but with just a simple fold?